Hi there. So today we're going to have a look at November 2022's paper 1 GCSE Maths Higher Tier, the Edexcel version. So this was set on early November, I believe, and non-calculator, and we're going to have a look at all the questions together. So some questions I'll show you multiple methods for, but as ever, all you need to understand is one method which makes the most sense to you. So if there's any questions on the video, please do leave a comment or contact me directly. But that said, let's have a look together at question number 1. Question 1 asked us to write down 500 as a product of powers of its prime factors. So what we need to do here is to first of all understand and realise that this question is essentially asking us to do a prime factor tree. So we start with 500 at the top, and then we just think about any number we can divide 500 by, and the answer to that division on the other side. Only rule is don't divide by 1. You need to think of a number bigger than 1 to divide it by. I would always consider if a number's even, the best thing is we can divide by 2. So 500 divided by 2, half of 500 is 250. The next step is, if we have a prime number, a number which can only be divided by itself and 1, we have to circle that. 2 is prime, we can only divide 2 by itself and 1. 250 isn't, so we do the same process again. So 250 is even, so I'm going to suggest we can divide it by 2. You don't have to, that's just my way of doing them. That gives us 125. 2 is prime, so that's why I've circled it. 125 isn't, so we go again. Now 125 isn't even, but that's not to say we can't divide it by something. 125, because it ends in 5, that means we can divide it by 5. 5 is prime, so we're going to circle it. So what is 125 divided by 5? Well, that's fairly easily answered by doing some bus-stop division. 5 into 1 doesn't go, so that 1 is still left over as a remainder. We put the remainder next to the 2, which now becomes 1, 2, which is 12. So next, 5 into 12 goes 2. 2 times 5 is 10. 10 is still 2 short of 12, so the next remainder is 2. Then 5 into 25 goes 5 exactly. No remainder, so we're finished. So 125 divided by 5 is 25. 25 isn't prime, we can go again, and hopefully at this stage, I'm hoping with a bit of motivation, you can fairly easily see that 25 is just 5 times 5. So 25 divides by 5 and becomes 5. So this now is the basis for working out our answer. So we need to write all these numbers as a product, which means multiplied together, in power form. So we've got 2 twice, and we have 5 3 times. So therefore, our answer is going to be 500 equals 2 to the power 2, because we've got 2 of them, multiplied by 5, and because I have 3 5s, that's 5 to the power 3. So in power form, as a product of its prime factors, 500 is 2 squared multiplied by 5 cubed. Question 2, some fractions. We need to work out 1 3/5 plus 2 1/4, giving the answer as a mixed number. First of all, if we're adding 2 fractions together, I would always suggest we get rid of any mixed numbers and put them as top-heavy or improper fractions. And the way of doing this is we take the whole number, multiply by the denominator, or the bottom, and then we add on the top number. So 1 3/5, we take 1 and 5, multiply those together. So 1 times 5 is 5, plus the 3 on top becomes 8/5. We leave the denominator as the same thing as what it was. 2 1/4, we change into a top-heavy fraction the same way. So we do 2 multiplied by 4, which is 8, then add the 1 on the top, which gives us 9. So 2 1/4 becomes 9/4. We can now add these two together, but only if we have a common denominator. So 5 and 4 aren't the same, so your teacher will have taught you, hopefully, a way of getting a common denominator for a fraction. Their way might be different to mine. This way will always work. You might need to simplify after, but what my tip is here to do, to get a common denominator, we take each corner, multiply by the opposite corner, and then the bottom 2 numbers for denominators, we just simply multiply together. I call this method cross cross smiley face. Some teachers call it the butterfly method. Whichever, it works either way around, whatever name it's called. So 8 multiplied by 4 is going to become 32. And the bottom numbers, 5 multiplied by 4 is going to become 20. So we have 32 over 20. And the second one, we're going to do 9 multiplied by 5. 9 multiplied by 5 is 45. And the new bottom number again is going to be 5 times 4, which is 20, which is what we want. We want it to be the same on the bottom. So now we have 32 over 20 plus 45 over 20. Now the bottom numbers are the same, we leave them as they are, so we leave that as a 20 and just add the top numbers, the numerators. So 30 plus 40 is 70, and 2 add 5 is 7. So we're going to have 77 over 20. But we want our answer now as a mixed number. So the final step is we need to ask ourselves how many times 20 fits into 77. So 20, 40, 60 is 3 times. 80 would be too high. So we can fit 3 20s into 77. 3 20s are 60. So we still have 17 left over. So our remainder is 17, and we write that over 20. So our final answer is 3 and 17 over 20. And 17 over 20 doesn't simplify, so we're fine to leave that exactly as it is. Part B, we have to show that 2 and 2/3 divided by 6 equals 4/9. Now actually we can do this one in 2 different steps, but I'm going to just suggest one step here. So let's just take this as it is and do 2 and 2/3 and just rewrite it out. So 2 and 2/3 divided by 6. Well, if we're dividing by 6, we can say that's the same as 2 and 2/3 divided by, I can rewrite 6 or any whole number as a fraction by writing it as itself over 1. So at this stage, the only thing I'm doing is sneakily rewriting 6 as 6 divided by 1, which of course it is. So why I'm doing that will become very clear in a moment. But now, like we did for part A, we need to make sure any mixed numbers become top-heavy fractions. So that 2 and 2/3 needs to change. So 2 times 3 gives us 6, and then we add the 2 on the top. So the 6 we had plus 2 gives us 8. So we can rewrite now this as 8/3 divided by 6 over 1. Now if we've got one fraction divided by another, most teachers I think use the same way. You might have called it KFC, which isn't quite right. But anyhow, what we do here is we're going to keep the first fraction as it is. We're going to change the division to the opposite of divide, which is multiply, and the last fraction we're now going to flip on its head. So after writing 8/3 divided by 6 over 1, we now say that's equal, the same thing as 8/3, change divide to a times, flip on its head to 1/6. So we now say this bit is equal to this bit, and that is the key bit of showing that the answer is going to be 4/9. But we're not quite done yet. We've got one fraction multiplied by another now. So we do 8 multiplied by 1 and 3 multiplied by 6. So 8 multiplied by 1 is 8. 3 multiplied by 6 is 18. And then this fraction can be simplified because 8 and 18 are both even numbers. So we can now simplify by dividing both top and bottom by 2. So 8 divided by 2 is obviously 4. 18 divided by 2 is 9. So we've clearly and successfully shown that this fraction calculation here does give us 4/9. Let's now have a look at question 3. Question 3 is about powers. So we need to simplify this in brackets and give our answer as a power of 2. So just remembering BIDMAS really, we need to work out the powers, work out the powers second, but the brackets first. But obviously inside the brackets is powers. So first of all, we can say 2 to the minus 5 times 2 to the 8 is the same as 2 to the minus 5 plus 8. Remember, when we've got powers and we multiply them together and the base numbers are the same, we add the little numbers together. We add the powers. And so 2 to the minus 5 plus 8, minus 5 plus 8 is 2 cubed. So in the brackets, it's just simply the same as 2 cubed. So all of this here in the brackets is just the same as 2 cubed. So therefore, this is just the same as 2 cubed all squared. If something's being squared, it just means it's being multiplied by itself. So all this means is 2 cubed multiplied by 2 cubed again. Now, I would say automatically as a first thing, normally, we just do 3 times 2, power of a power. But I'm just mentioning this way now so you can see why it works. Because that number's small, it's not hard for me to write this out twice. So 2 cubed squared is 2 cubed multiplied by 2 cubed. This is 2 times 2 times 2, multiplied by another 2 times 2 times 2, which of course is 2 to the power 6. We don't need to work this out, we're asked to leave it as a power of 2, so our final answer is just simply 2 to the power 6. And that's a 6, because it's 3 times 2. Question 4, work out 0.004 multiplied by 0.32. So we're multiplying 2 decimals together, but the trick here is not to worry about the decimals. We're actually going to do this by just considering these as whole numbers, which I'll explain now. So, there are a few pointers here. So, the first thing to mention, step 1, we need to note down the total number of digits after the decimals in the question. So we've got here a point there and a point here. So let's just total up how many digits come after these dots. After we've done that, we're going to imagine the decimals vanishing, and then we're going to perform the multiplication with those whole numbers instead. And after that, using step 2, we're going to pop the decimal point in after so that the answer has the same number of decimal places as it was at the beginning. So first of all, step 1, how many digits come after these decimal places? Well, there's 1, 2, 3 there, 0, 0 and 4, and the 3 and the 2 there, that's another 2. So 3 plus 2, that gives us a total of 5 decimal places. Step 2 now, I'm going to imagine these decimals vanishing and imagining what this calculation would look like if the decimals vanished and they just looked like whole numbers. So this first number here would look like 4, and this number here would look like 32. So if I now imagine them vanishing, these decimals, it just becomes 4 times 32. So if we just try to do what 4 times 32 is, and just take a moment or two to perform that calculation, hopefully you'll realise and be able to do correctly that 4 multiplied by 32 gives 128. So now we've got the number 128, we can now imagine step 3, inserting the decimal point so that the answer has the same number of decimal places as the value from step 1. So from step 1, in total there's 5 decimal places. So what we need to do, starting from the end of the 8, we need to count 5 places inwards. So 1, 2, 3, 4, 5, then the decimal would go here, something a bit like this. So that's where the 5 decimal places would be. So obviously the last 3, 4, 5 are the 1, 2, 8. I've got nothing in this place, nothing in this place, and nothing before the decimal, which looks slightly strange, of course. So what's nothing mathematically? We need to insert a 0 in each empty space, because as obviously you've remembered that nothing mathematically is represented by a 0. So nothing, nothing, nothing must become 0, 0, 0, like so. So our final answer is 0.00128. So that's our final answer, therefore question 4 completed. Question 5, a car factory is going to make 4 different car models, A, B, C and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information about the results, so we've got people that would choose car A, car B, car C and car D, and they total 23, 15, 30 and 12. The factory is going to make 40,000 cars next year, and they want to work out how many Model B cars they should be making for next year. So they're going to be making 40,000 in total. How many of those 40,000 cars should be Model Bs? So the first way of thinking about this one probably might be a fraction of amount. So this, I think, might be the most logical, most straightforward way of doing it. I'll show you another way after, but fractions of amounts. So 80 people were asked what model car they'd be most likely to buy. We're interested in how many people would choose Model B, because we're wanting to think about how many Model B cars the factory should make. And 15 people obviously said they'd go for a Model B car. So 15 out of 80 people chose Model B. So that proportion, that fraction, has to be the company's best estimate of the proportion of the population that might buy these 40,000 cars in total. So in other words, if 15 out of 80 people chose Model B, then we can frame this as a fraction and say that the best estimate that they should be making is 15/80ths of the cars should be made as Model Bs. So we need to be thinking of what is 15/80ths of 40,000. First of all, I'd suggest to see if we can simplify down the fraction 15/80ths. Luckily we can, because both numbers end in either a 5 or a 0, which means we can divide them both by 5. So 15 divided by 5 is 3, and 80 divided by 5 would give 16. So we need to calculate essentially 3/16 of 40,000. So first of all, what I'm going to do is calculate 1/16 by dividing 40,000 by 16. So 1/16, if I just put this here, 1/16 for 40,000. I could either jump straight into doing a division, doing 40,000 divided by 16 using the bus stop straight away, or what I could do is think of this as being 1/16 multiplied by 40,000 over 1. In other words, I can actually frame this as being 40,000 on top and 16 on the bottom by just doing the numerators multiplied together, and the same with the denominators. So 40,000 all over 16. Now both 40,000 and 16 are even. That means we can half the top and half the bottom. So we get 20,000 over 8. Again, still even, so half again. We're going to get 10,000 over 4, still even. Well, at this stage, you might be able to do this directly, of course. So 10,000 divided by 4, if you want to do it directly, would be 2,500. Therefore, if 1/16 of 40,000 is 2,500, then 3/16 of 40,000 must be 2,500, which was 1/16 multiplied by 3, which is 7,500. So therefore, the projected number in total of Model B cars which should be made should be 7,500, because this is 3/16 of, the 40,000 cars, I mean to say. 3/16 of 40,000 is 7,500. So method B is essentially a scaling method. So for method B, considering scale and proportion now. So we've got 80 people asked what type of car they'd likely buy. The factory is going to want to make 40,000 cars in total. We're interested in the Model B cars, and out of the 80 people, 15 of them said they'd likely buy a Model B car. So what we can imagine now is these number of people actually not just being a single person, but being essentially a representative for the entire population of the potential 40,000 that could be buying all the cars. So 23 plus 15 plus 30 plus 12, well, there's 80 people. We can imagine those 80 people as being 80 lots of people, representing proportionally the total number of 40,000 cars. So if 80 people in total are representing proportionally those 40,000 cars, in other words, if 80 groups of people are going to be buying 40,000 cars in total, how much would each group or each cluster of people, however you want to frame it as a ratio, would each group of people be buying? So we'd need to be doing 40,000 divided by 80 to find our scale factor, which would take us from this column to the final column, for the number of people translated to the number of cars that should be made. So we need to essentially do 40,000 divided by 80. Well, both numbers end in a 0, so we can knock those off. So we can then do 4,000 divided by 8. 4,000 divided by 8, both numbers are even, so half of 4,000 is 2,000, and half of 8 is 4, and then 2,000 divided by 4 gives us 500. Therefore, the scale factor from this column to the final one is to multiply by 500. So we'd need to multiply all these values by 500 if we were interested in how many types of cars of each model, but we're not. We're only interested in model Bs. So all we need to do is just for 15 multiplied by 500. 15 multiplied by 5 is 75. Add on the 2 zeros, that gives us 7,500. Question 6. Rizwan writes down 3 numbers A, B and C. So for part 1 of A, we need to find A to B to C. So the first piece of information, in terms of ratios, we're told that the ratio of A to B is 1 to 3. We're then also underneath obviously told that the ratio of B to C is 6 to 5. So we can put both ratios of A, B and C, all 3 variables, into a ratio table like so. So we've got A to B, which was 1 to 3, and then B to C we can put underneath as 6 to 5. So our mission now is to get these values to line up and also to meet and greet onto the same final line. So currently the B values don't line up because 3 isn't the same as 6. However, we could easily get B to match 6 by multiplying it by 2. But to keep the proportion the exact same in this whole top line, the first top row, if I'm multiplying the 3 by 6 to match, if I'm multiplying the 3 by 2 to match the 6, I'd have to also multiply the 1 by 2 to keep that in proportion as well. So what I need to do first of all is multiply both the 1 and 3 by 2, and that would get me down here to 2 and 6. The B in the blue line is already a 6, so I can just keep that as a 6, and then that's 5. So I have 2, 6 in red, 6, 5 in blue. So overall, I've got 2, 6, and 5. So the overall ratio of A to B to C is 2 to 6 to 5. So get the red to match the blue, then merge and combine the lines into 1. That's the final answer, 2 to 6 to 5. For part 2 of part A, it asks us to express A as a fraction of the total of the 3 numbers A, B and C. So express A as a fraction of all 3 numbers A, B and C. So A is 2 parts. So A is essentially just 2. But the whole total of numbers, if you have a look at all of them, is actually 2 plus 6 plus 5. So when it asks about the total of the 3 numbers A, B and C, the total of all those numbers, 2, 6 and 5, is that. So the overall fraction of A as a grand total is 2 over 2 plus 6 plus 5, which of course can be given much better. If we just work out 2 plus 6 is 8, then add 5, it's of course 2/13. So A as a fraction of a total, 2/13. Let's have a look now at part B. So part B, Emma writes down 3 numbers M, N and P. So N equals 2M and P equals 5N. So we're wanting the ratio, apparently, of M to P. So again, this can be done as a table. So M on one side, P on the other. Let's work out what this will be in simplest form. So far, all we've told really is what P is. So P is 5N. We're told what N is, but not what M is. But if we're told that 2M is N, essentially what we could do to both sides here is divide by 2. Therefore, hopefully you can see that 1M would be half of N. So M would be N divided by 2. So that's what we can plug in for being M. So we can say that M is N over 2. So we've got one line for our ratio, but obviously that's not going to give us full marks. It may give us some credit, but not full. Essentially, ratios will seldom have fractions within them. A fraction might be a fraction, a ratio may be a ratio, but very rarely, sometimes, but rarely they're mixed. Essentially, if you can avoid having a fraction within a ratio, do so. So if I've got half of an n here, I could just multiply by 2 to make it into a whole n, but to keep it in proportion, obviously I need to multiply the 5n by 2 as well. So then, essentially, I've got that m is equivalent to n if p is equivalent to 5n times 2, which is 10n. So now if we just think about this and just take a step back mathematically slightly. This is just saying whatever m is, if I just call m n, which is confusing, whatever n is, p is 10 lots of that. So if n were 2, p would be 10 times 2. If n were 3, p would be 10 times 3. So it's just saying that whatever m is, p must be 10 times bigger. In other words, for any 1 unit of m, p must be 10 units, essentially just by cancelling the n's from both sides. So the final simplified ratio of m to p is 1 dot dot 10. Question 7 is about pressure, force and area. Unfortunately, you're given the formula here, so there's no need to panic, which is obviously great. So we're told a storage tank exerts a force of 10,000 newtons on the ground. The base of a tank in contact with the ground is a 4 by 2 rectangle. So it's 4 meters by 2 meters. Work out the pressure on the ground due to the tank. So as long as you keep your head, this is actually a very simple question indeed. So first of all, I'd suggest we note that the force is exerting 10,000, so the box is exerting a 10,000 newtons force on the ground. Therefore, we know the force here is equal to 10,000. So we've got that in our equation already. The other thing we need to work out is the area, but we are told that the base of a tank in contact with the ground is a rectangle which is 4 long and 2 wide. So the area of a rectangle is length times width, which is 4 multiplied by 2, which is 8. So essentially, because we know it's 4 long and 2 wide, we know the area is 8. So 4 times 2, of course, which becomes 8. So 10,000 over 4 times 2, well, that becomes 10,000 over 8. What I've done here is just halved both the 10,000 and the 8. So half of 10,000 goes to 5,000. Half of the area, which was 8, becomes 4. Then 5,000 divided by 4, you could half again because both 5,000 and 4 are even numbers. That gives us 2,500 over 2. And then what we could do is just half 250. So half of 250 is 125, plus the extra 0 will be 1,250. Therefore, the pressure on the ground due to the tank is 1,250 newtons per metre squared. Question 8, we have two numbers m and n, such that m is a multiple of 5, n is an even number. So m is a multiple of 5. In my mind, the simplest way of putting that is m is your 5 times table. N is an even number, so n is the algebraic representation of the 2 times table, because a 2 times table is all of the even numbers in sequence. So what I'd suggest we do first of all is just think about m, 5 times table, and n, the 2 times table, on a line written out. Okay, so multiples of 5s in red, multiples of 2s, evens in blue on the bottom. We want to work out the highest common factor we're told, the highest common factor of m and n is 7. So in plain English, what this means is 7 fits into both m and n. And not only that, 7 has to be the biggest thing that fits into m and fits into n together. So if 7 fits into m and n, that's another way of saying that m must also be in the 7 times table, and n must also be in the 7 times table too. So for the red numbers, let's spot out any numbers which are also in the 7 times table, and for the blue numbers, again, underline any numbers which are in the 7 times table in blue. So in the red, we can hopefully see that 35 is a multiple of 7, as is 70, that's 10 times 7, and in the blue, 14, that's 7 times 2, and also 28, which is 7 times 4. So we can underline these four numbers, which are multiples of 7, but we want the highest common factor of the red and the blue to be 7. So we want to keep our numbers as small as possible, really. So if we went for 70 and 28, for example, the highest common factor of those wouldn't be 7. 7 would be a common factor, but it wouldn't be the highest, because we've doubled 35 to get to 70, and we've doubled 14 to get to 28. So the highest common factor of these two would be the highest common factor of 35 and 14, which is 7, multiplied by the 2 we've scaled up by. 7 times 2, the highest common factor would be 14 of these. So get multiples of 7, and then pick your lowest set. And so the lowest set here, the lowest 7 times table value of m is 35, and the lowest 7 times table for n is 14. So we're going to disregard 70 and 28 and just go with 35 and 14. So the possible value of m and a possible value of n, the most obvious appealing one I can think of is just 35 and 14, like I've said. So write down m is 35 and n is 14, and then we're done. Question 9, part A and part B relates to a cubic graph with negatives involved too. So it's 6x minus x cubed. We've got negative numbers to compute as well for x, and it's a non-calculator paper. So I'm going to make no apologies for just doing this step by step by step, brute force, just doing it really slowly and really carefully. You really need to be so careful with negative numbers at the best of times. So even though part A just looks ostensibly like we're just working out 4 values in a table, these 4 missing values need to be treated with the utmost of respect. So let's build up to working out what y is by considering what y is composed of. So y is composed of 6 multiplied by x, then once we've done that, we then subtract away whatever the corresponding value of x is, cubed. So I'm going to suggest we expand upon this table here and just jot down something like this. So I'm going to suggest a table like so. So first of all, let's fill in our x values. So x ranges from -3 all the way up to 3 in steps of 1 unit. So the first component, as I've said, is that we need y to be considered as partly 6x. So 6x is the first bit we need to work out. So firstly, if x were -3, 6x would be -3 multiplied by 6, which would be -18. This second row here, if x were -2, 6x would be -2 times 6, which is -12. -1 times 6, -6. 0 times 6 is 0. 1 multiplied by 6 is 6. 2 multiplied by 6 is 12. 3 multiplied by 6 is 18. So now we've got all the values of what 6x is. The next thing, I'm not going to consider this minus sign here first. I'm just going to consider the x cubed part. So the next component, now we've got our 6x component, let's think about the x cubed component of this equation for y. So x cubed means whatever x is, we take its value, multiply it by itself once, and then multiply it by itself a third time. So if x were -3, x cubed would be -3 multiplied by -3 multiplied by -3. -3 multiplied by -3, first of all. A minus number multiplied by a minus always gives us a positive. So -3 multiplied by -3 is +9. We're then multiplying this +9 by a -3. So taking it nice and slowly and carefully, what we'd need to consider is that this bit here becomes +9 times -3, and +9 times -3 actually gives us -27. So when x is -3, x cubed is actually -27. The next row, when x is -2, x cubed is -2 multiplied by -2 multiplied by -2. Phew. So in the same way as before, -2 multiplied -2 gives us +4, and then positive 4 multiplied by minus 2 takes us into negatives again and gives us minus 8. When x is minus 1, x cubed is minus 1 times minus 1 times minus 1. Minus 1 times minus 1 is positive 1, but multiply it by another minus takes us to minus 1. Now we get into the non-negatives, and that makes it much easier. When x is 0, 0 cubed is 0, because 0 times 0 times 0 is 0, obviously. When x is 1, x cubed, 1 multiplied by 1 multiplied by 1 is 1. When x is 2, 2 cubed is 8. And when x is 3, 3 cubed is 27. Now we need to consider the fact we're doing 6x minus x cubed. And that will tell us, obviously, what y is. So first of all, when x is minus 3, 6x was minus 18. And I'm going to subtract away from that minus 27. So I need to think about minus 18 subtract minus 27. So it's actually minus 18 minus minus 27. Two minuses together like that I can consider as a plus. So minus 18 plus 27. The positive value here, the 27, is a bigger looking number than 18. So because 27 is positive, the number is going to be positive overall. My suggestion would be the negatives. Start with the positive part, and then what your negative number is, think of that as what you're subtracting away. So think of this as being positive 27, in other words, just normal 27, minus 18. 27 minus 18 gives us positive 9. The next row, when x is negative 2, 6x will be minus 12, and I'm going to minus from that minus 8. So I've got minus 12 minus minus 8. Like I said from before, that's the same as minus 12 plus 8. If it were minus 12 degrees in Siberia, it then gets warmer by 8 degrees. It'll still be fairly cold. It then go to minus 4 overall. So start down at minus 12, go up by 8, minus 10, minus 8, minus 6, minus 4. When x is negative 1, 6x is minus 6. Then we're going to minus away minus 1. 6x minus minus 1 is the same as, sorry, minus 6 minus minus 1 is the same as minus 6 plus 1. So starting at minus 6, go 1 higher. That would take us to minus 5. When x is 0, really straightforward. 6x minus x cubed is just 0, subtract 0, which is 0. When x is 1, 6x minus x cubed is 6, subtract 1, which is 5. When x is 2, 6x subtract x cubed is 12 minus 8, which is 4. Then finally, we go back into negatives again when x is 3, because then 6x take away x cubed is then 18 minus 27, which then gives us minus 9. So the key points we want to add in here are from minus 2, minus 1, 0, and 1. So we're going to add in these points here into the table, minus 4, minus 5, 0, and 5, like so. So that's part A complete. Part B is then actually plotting these onto the grid accurately and drawing the graph with a smooth curve going through each and every point. So the first coordinate we've got is when x is minus 3, y is 9. So first of all, we plot that one over here. Next of all, when x is minus 2, y is minus 4, which goes down here. We then have minus 1 and minus 5, which is going to be here. Then 0, 0 through the origin. Then 1 and 5, which is up here. Then 2 down to 4 again. And then 3 down to minus 9, like so. Your idea now is to try and do a smooth curve going through all these points, dot to dot to dot, not using a ruler, but using a smooth curve. I'm going to cheat now because I can do, so no. Here's my version now in a almost perfect blue cubic. And even that's not perfect. As you can see, it doesn't quite go through the center of each dot even perfectly. So even me cheating, I can't cheat perfectly. And the examiner will give you what's known as tolerance for that. So if your line is slightly squiggly or you look to be nervousness shaking a bit, don't panic too much, but do focus on getting your curve to go through the center of the dots. That's the most crucial thing for plotting this cubic in question 9. Question 10. Lena spins a biased 5-sided spinner 40 times. Here are results. So she scored a 1 6 times, a 2 8 times, a 3 9 times, a 4 she got 7 times, and a score of 5 she got 10 times. So because it's biased, that's why the numbers aren't all equal. You'd expect them to be closer to 8 each, and to be fair, it doesn't seem that biased, but because it is biased, you can't really argue that's why 5's quite high and the number of 1s are quite low. So anyway, what she's going to do now is to spin the spinner another 2 times. We need to work out an estimate, not a guess, but based on this table, an estimate for the probability that she gets a score of 5 both times. So the first part of this question is to show to the examiner that we can get a good estimate from these relative frequencies. So just thinking of this table and expanding upon it, if she spins a 5-sided spinner 40 times, then we can work out an estimated probability for each of these scores based on her relative frequencies. So of those 40 times, she got a 1 6 out of 40 times. So 6 out of 40 simplifies down to 3 out of 20. So our best estimate for the probability of her spinning a 1 would be 3/20. She spun a 2 8 times out of 40, and that simplifies down to 1/5. So the best estimate of her spinning a 2 is 1/5. She spun a 3 9 times out of 40, so that's our best estimate of spinning a 3. She spun a 4 7 times out of 40, in the same way that's the best estimate of scoring a 4. And she scored a 5 10 times out of those 40, and 10/40 simplifies down to a quarter because both 10 and 40 can be divided by 10. So using these values now as our estimate, we want to consider the chance of her getting a score of 5 both times. Well, the chance of her spinning a 5 once is a quarter, as we can see here. So the chance of, I should say spinning really, chance of spinning a 5 is a quarter. It's 10 out of 40, which goes to our quarter, which is our best estimate of the probability of spinning a 5. So if she spins it twice, the chance of getting a 5 both times, the chance of spinning, a 5 twice, is a probability of spinning a 5 on the first roll and then spinning a 5 on the second one too. So the probability of one thing and then another, if you're wondering why I'm shouting in block capital red, is that if you can consider a probability question as one event and then the probability of something else happening, the word and or words and then will almost always translate into a multiplication. So it's the probability of rolling a 5 on the first one, which is a quarter, multiplied by the probability of spinning a 5 on the second one, which will also be a quarter, because this spinner isn't going to get damaged or figured with or changed in between the 2 rolls, so you assume the probability is going to be fixed. So 1/4 for the first spin, multiplied by a quarter for the second. 1 multiplied by 1 is 1, 4 multiplied by 4 is 16. So a quarter times a quarter is 1/16. That's our estimate of a probability that she scores a 4 both times. Derek now is going to spin this spinner a large number of times, it says, and we want to work out an estimate of the percentage of times Derek can expect to get a score of 1. Well, looking at this table, score of 1, Lena got a 1 6 out of 40 times, which is 3/20. So the best probability of scoring a 1 overall is 3/20. So the fractional probability of rolling a 1 or scoring a 1 is 3/20, but we want this as a percentage. So a percentage isn't out of 20, a percentage means out of 100. So we've got 2 options now. We could either work out the percentage by doing 3/20 multiplied by 100, or thinking what 3/20 of 100 is. What I'm going to do here, though, is to consider a percentage as meaning the denominator needs to be 100, and considering what we need to multiply 20 by to get to 100. Well, clearly what we'd need to do is to do 20 multiplied by 5 to get 100. Therefore, we need to do the same to the top. 3 multiplied by 5 is 15. We therefore get 15 out of 100, which is the same as 15%. So the estimate for the percentage of times Derek can expect to score a 1, we'd say 15% of the time. Question 11, we have to describe fully the single transformation that maps shape P onto shape Q. Now, importantly, it says single transformation. A common mistake I see students make is say that it's like a reflection, then it's been rotated, or something like it's been translated, then we have a reflection. No, it's just describe it in one single move, what happens to go from P to Q. And also read the question carefully. We're going from shape P to Q, from the big one to the small one. So even though you're going from a big trapezium to a smaller one, because it's changing size, it has to be therefore called an enlargement. An enlargement is when it changes size. So it's not called a shrinking when it gets any smaller, it's still called an enlargement. So the first thing to note down is this one is an enlargement. The second thing we need to think about is the scale factor of enlargement. And what we need to do to work that one out is we need to consider two corresponding sides of the original shape and the new shape. So I could have taken here the top side of P and the top side of Q and compared those, or I could take the bottom side of P and the bottom side of Q. That's what I'm actually going to choose to do. So P, which I'm going to do in blue, this one here is 3 squares along, whereas Q there becomes 1 square along. So it's gone from being 3 squares down to just being 1 square. And to get the marks for describing the transformation, we need to describe the scale factor of enlargement. And to work out the scale factor of enlargement, using these two corresponding sides and their corresponding lengths, there is a nice formula we can use. The scale factor is basically the length of the new divided by the length of the old. So the new sides become 1, it used to be 3, so 1 divided by 3, just leave it as a third. Therefore the scale factor of this one is a third. The final thing we need to get full marks is to give the centre of enlargement. And what we do now is we get a ruler and join each point through to its corresponding point and then extend the line going further and forward. So the first one, from this corner through to the new corresponding corner, going further, we go through this point here. If we do the other one, that top right through this top right and extend the line again, goes through this point too. The bottom right through that bottom right, extend the line, and finally the bottom left points. And you'll see always, in fact, these points will converge, and where these lines converge is always going to be the centre of enlargement. So you can see here they converge at the coordinate 0, 2, when x is 0 and y is too high. Therefore, to get the final piece of evidence to get full marks, we say the centre of enlargement is the coordinate 0, 2. So it's an enlargement, scale factor 1/3, centre 0, 2. These used to be 3 marks for saying each of 3 bits of information. Sadly now they're not always as generous, but you still need to say these 3 bits. Be very careful to mention every single one of these 3, otherwise not full marks. Question 12, we have to solve some simultaneous equations. So we've got 5x plus 2y equals 11 on top, and on the bottom we have 4x plus 3y equals 6. There are different methods for solving simultaneous equations, but I'm just going to run through the most common one used in schools and probably across the land and maybe even in other countries, which is this process of called elimination. So we're going to aim to either get rid of the x's or the y's from one equation so that we can then focus on working out the other variable. So eliminating y is going to be the first one I'm going to show you. Method B after, I'll show you how you could do it if you chose to get rid of the x's. First of all, to eliminate the y's, what we'd need is to multiply both the top and the bottom equations together so that both of the y numbers match. So what's the smallest number in the 2 and the 3 times table? Well, the smallest number is 6. So what I could do here, I could get both the y numbers to become a 6. I could multiply the top equation by 3 and the bottom one by 2. So if I did that, the top equation would become 15x plus 6y equals 33 when I multiply everything by 3. And doubling all of the bottom gives me 8x plus 6y equals 12. I can now see my numbers in front of the y's match, both are 6's. Once the numbers match, I then look at the signs immediately in front of those matching numbers and see if those match or not. So here I can see both are plus signs. Now, what I would say, some teachers say DAS, different add, same subtract. I tend to say when the signs are the same, we subtract. Therefore, if they were different, you'd add, therefore. So plus and plus, they're the same sign. The signs are the same, therefore we're going to subtract. We're going to do the top equation, subtract the bottom. So 15x take away 8x gives 7x. For y's will cancel. 33 take away 12 gives 21. 7x equals 21. We can now choose to divide by 7 on both sides. X is therefore 3. Now we know that x is 3, we can substitute this value of x back into one of these initial equations to work out what y would be. So if I substitute x is 3 into this first equation here, 5 times x is the same as 5 times 3. So this is the same as saying 5 times 3 plus 2y equals 11. So 5x, 5 lots of 3 is the same as 15 therefore. So 15 plus 2y is 11. I need to solve it. To get y on its own, I could subtract 15 from both sides. So 15 take 15 will give me just 2y over here. On the right hand side, 11 minus 15 will give me minus 4. So 2y is minus 4, therefore divide both sides by 2, y must be negative 2. Therefore the full solution is x is 3 and y is minus 2. The other way of doing it would be to eliminate x, which is what I'm going to show you now. Obviously I only need to do it one way, of course. So the second way, what if we had eliminated x? So what we'd need to do there would be to get the numbers in front of the x's to match. So 5 and 4 to match, and be thinking what's the smallest number in the 5 times table and the 4 times table? Well, I can get them both to become 20. I could do the top number times 4 and the bottom number times 5. So what I could do here, to get the x numbers to match, I could multiply the top equation by 4 and the bottom equation by 5. If I did that, the top equation, multiplying everything by 4, will become 20x plus 8y equals 44, and the bottom one, multiplying everything by 5, gives 20x plus 15y, and 6 times 5 is 30. So now, of course, the numbers of x's match up. I now consider, because these numbers match, the signs in front of them, and say if they're the same or different. Now, there's no signs in front, so you can always assume if a number has no symbol in front of it, but it's a positive value. So I've put in brackets positive, so you can consider the first one as a positive 20x. The second one you can think of as being a plus 20x too. So these signs, are they the same or not? Well, both are plus, both are positive. The signs are the same, therefore again, we're going to subtract. We're going to do the top equation, take away the bottom. So 20x take away 20x will cancel. 8y minus 15y, that'll give us minus 7y, and 44 take 30 gives 14. So minus 7y equals 14. To get y on its own, I'd have to divide both sides of this equation by negative 7. 14 divided by 7 is 2, so 14 divided by negative 7 is negative 2. Now I know that y is minus 2, I can then plug this value of y back into one of these initial equations. So if I go for the top equation, 5x plus 2y equals 11 would then become 5x plus 2 lots of minus 2 equals 11, because y is minus 2. 2 lots of minus 2 becomes minus 4, so I can replace 2 times minus 2 with minus 4. Plus minus 4 overall is a minus 4. So 5x minus 4 equals 11. I can then add 4 to both sides of the equation. That gives me 5x is 15. Finally, dividing both sides by 5, x must therefore be equal to 3. So the final full solution, once again doing it a different way by eliminating x instead of y, we still get the same solution, that x must be 3 and y is minus 2. Question 13 is about inverse proportion. So we're told that p is inversely proportional to t. So if we're talking a question about inverse or direct proportion, we would normally use a symbol that looks like a fish. And so whether it's proportional or inversely proportional, whatever is written first, in this case p, then in place of proportional or inversely proportional comes the fish symbol. And then if it's inverse proportion, rather than just writing down t, is going to be the reciprocal of that. So inverse replies reciprocal. So p reciprocal of 1 over t. So what we're doing here is saying p is proportional to 1 over t. Obviously, though, fish aren't very good at doing maths. Dolphins perhaps, but fish definitely not, brains too small. So we replace this symbol here with an equals, then k for constant to find, multiplied by what p is inversely proportional to, in this case 1 over t. So we rewrite this one as p equals k multiplied by 1 over t. So that would simplify to p equals k over t. And then we just need a pair of points for both t and p, which we know, to work out this constant k. So we can see here, we know when t is 100, p is 1. So if we substitute that p is 1 and t is 100, we'd get that 1 equals k divided by 100. So rearranging this, k would have to be 1 multiplied by 100, which is, of course, just 1. Or you could think of it in terms of 1 equals what fraction of 100? Well, 1 full unit would be 100 out of 100, it's 100%. Either way, you need to know that k is 100. Knowing this, we can then work out the missing values in the table, because we've now essentially got a full equation for what p is. So p equals 100 divided by t. So using this equation like here, or using a magic triangle, which I've got here for you as well, we can work out p or t as long as we know the other one. All we need to remember is to cover up the value which we're trying to find out. So for this one here, we know obviously t is 25 and we're trying to find p. So we're trying to work out p, so cover up p. So p is going to be 100 divided by whatever t is. So if t is 25, p will be 100 divided by 25, which will give us 4. For this one here, now we're trying to work out t. So if we're trying to work out t, cover t up, therefore t will be 100 divided by whatever p is. So if p is 5, t will be 100 divided by 5, which is 20. Finally, if I'm trying to work out p when t is 2, cover up p if I'm trying to find it. So therefore p will be 100 divided by t. So I've got 100 divided by 2, which gives 50. So the missing totals in the table are 4, 20 and 50. Now there is an easier trick to this as well, which I'm going to mention. If two variables, in this case p and t, are in inverse proportion to one another, we can always say this is true. So if it's two variables, call them a and b, are in inverse proportion to each other, then one multiplied by the other will always be the same thing. So here we knew that t multiplied by p was 100. So with this trick we should know that, well, all of these pairs, when you times them, need to be 100. So 25 multiplied by what gives us 100? That has to be 25 times 4. 5 has to be multiplied by 20, and 2 needs to be multiplied by 50 to get to 100. This will always work, but just pay some slight attention if, for example, you've got p inversely proportional to t cubed. If p was inversely proportional to t cubed, for example, it wouldn't be that p multiplied by t is the same. It'd be that p multiplied by t cubed is the same thing. So it will always work, but just take care when using it. Question 14 is about the weights of some potatoes, but in particular the actual topic is histograms. So on the grid we're going to draw a histogram for this information. So when we think about histograms, I tend to think about chicken wings. Now this is particularly stupid. I apologise in advance sincerely for how stupid and silly this is, but because it's so silly, students say to me they tend to remember it. So why am I talking about chicken wings? Because what attracts chicken wings is people that like to eat chicken wings. And some people that like to eat chicken wings are including the group known as fat dads. Those sure look mighty tasty to me, he says, with my terrible impression of accents, which is probably why I'll never do that ever again in my life. So essentially, this fat dad is eyeing up those chicken wings. Why? It's because you should know that fat dads feast on chicken wings. And this is a very particularly stupid way of remembering an equation which is priceless for histograms. So if it's a histogram question, it's that frequency density equals frequency divided by class width. Fat dads, frequency, chicken wings. Completely stupid. I apologise again. Ignore me if it's offensive, it may be. I don't know. Anyway, as long as you remember, that's the main thing I'm worried about. So, frequency density is the frequency, which is basically the totals in each row, divided by the class width. So the class width for each interval, each of these groups, is just the difference in between the higher number and the lower number. Difference between the upper bound and lower bound. So here the first class width would simply be 20, because 70 take 50 is 20. So let's work out the class widths first. So if I just add in a little column here for class widths, the first one would be 20. The next one from 70 to 80 is a width of 10. From 80 to 90 again is a width of 10. But then from 90 up to 110, that's a width of 20. We can now work out the frequency densities by taking each frequency and dividing it by the class width. So for the first row, we're going to have a frequency of 20 divided by a class width of 20. So that's going to be 20 divided by 20, which will give us 1. So I'm just highlighting the frequencies in blue. So firstly, 20 divided by 20 is 1. The next one, 50 divided by 10 is 5. 60 divided by 10 is then 6. And finally, 30 divided by 20 is the same as 3 divided by 2, which is 1.5. And so the frequency density is essentially the height of each bar. So now we can draw on these bars. So the first bar is going to go from 50 to 70, like so, and is going to be 1 high on this frequency density. So what we need to do now is to add on a sensible scale for our frequency densities, going up to at least 6. I would say here that 10 little squares could be worth 1 unit, like this. So that's my scale. So the first one, from 50 to 70, is going to have a height of 1. So it's going to be a box like so. So that's the first block. The second block is from 70 to 80 and is going to be 5 high. So very tall and thin looking. Should look like this. The second one has a width of 10 and is even taller. And the final block from 90 to 110 is going to be 1.5 high and goes from 90 to 110 like so. So the final block looks like this. So that's what your complete your complete histogram should look like. Question 15, we have a diagram showing a sector of a circle of radius 18 centimeters. The length of the arc is 4 pi centimeters. Work out the value of x. Well, first what it says about this arc, well not first of all, but you know, here it says about the length of the arc. An arc is essentially just a piece of the edge of a circle. So the arc here is from here to there, from that point to that point. It's just a fraction of the edge of a complete circle. Here we just got a fraction, a piece of a full circle. I'll come to that in a moment. But if this is 4 pi, it just means this distance from there to there is 4 pi. So imagining it as a full circle in this dotted blue colour here, we can see here that 4 pi is clearly just a tiny fraction of the full length all the way round this imaginary circle. And all the way around the edge of a circle is called the circumference. So in a moment we're going to consider this arc as a fraction of the complete circumference. We're told the radius is 18 from the edge to the centre, so I'm going to add this in and emphasise it with a green line. But like I mentioned, if the arc is a fraction of the circumference, we need to work out the circumference. And to work out the circumference, we need to know a length which is called the diameter of a circle. And the diameter goes from one end all the way to the other, like this blue line. This blue line is a diameter, and we need to know that the diameter is always double the radius. Hopefully you can see it here anyway. So from the edge to the middle, and then from the middle to the edge again. So it's going to be 18 plus 18, or 18 multiplied by 2, which is 36. There is an equation for it if you really want to use it. It's that the diameter is 2r. So d equals 2r, which means 2 multiplied by the radius, in this case 2 times 18, which is 36. So I can label this blue line, the diameter, as 36 centimeters. So now we can work out in purple the circumference, which is all the way from one end to the other. So the circumference is pi multiplied by d. To work out the circumference, you take the number pi and multiply it by the diameter. We now know the diameter is 36, so pi d means pi multiplied by 36, which in terms of pi is just 36 pi centimeters. So now we know the arc is 4 pi, but the full circumference would have been 36 pi. We can now work out what the arc is as a fraction of the complete circumference. So if that's 36 pi, then the arc as the overall circumference is 4 pi out of a total of 36 pi. We can then cancel pi on the top and the bottom, so we now have a fraction of 4 out of 36. That would simplify. I could half both 4 and 36 to 2 out of 18. I could then half again, which gives me 1 out of 9. So the arc as a fraction of the circumference is exactly 1/9. So in plain English, what this tells us is the arc is basically representing 1/9 of a full circle. So in the same way, this angle x there will just be 1/9 of the full degrees in an entire circle, which would be 360. Because the arc is 1/9 of the overall circumference, essentially this slice here is just 1/9 of your full circle. Okay? It's not like pizza where they give you eighths. It's a different pizza shop. It's been sliced into ninths. So x is 1/9 of a full circle. So we could say, if we wanted, that x as a fraction of a full 360 is 1/9. So one way we could consider it is as equivalent fractions. To go from 9 to 360, what would I multiply by? Well, to go from 9 to 36, I'd multiply by 4. Therefore, to go to 360 would be to multiply by 40. Therefore, do the same at the top. X must be 40 degrees. Or doing it as a simple fraction, if this angle x is 1/9 of your full 360, just work out what 1/9 of 360 is by doing 360 divided by 9, which of course would be 40. So therefore x is 40, this missing angle, 40 degrees. Question 16, we're going to prove that 2m plus 1 all squared minus 2n minus 1 all squared equals 4 lots of m plus n brackets m minus n plus 1. First of all, don't be intimidated by this. I'm going to show you two ways of doing it. One way which is a bit of a cop-out, but is valid. So we've got two brackets squared to work out. I'm going to do one in red, one in blue, then combine. So I tend to use the grid method for these. So if I'm going to set up two different grids, one for the 2m plus 1 all squared and another grid for the 2n minus 1 all squared, like I said, I'm going to work these out separately, then combine one, subtract the other. So first of all, 2m multiplied by 2m, well 2 times 2 is 4, m multiplied by m is m squared. Over here, 2m multiplied by 1 is 2m. Down here, 2m multiplied by 1 is the same. And 1 multiplied by 1, of course, is 1. So simplifying all this down becomes 4m squared plus 4m plus 1. So this here is the same as 4m squared plus 4m plus 1, and we're going to minus away what we get when we expand out this one in blue. So 2n multiplied by 2n squared is 4n squared. 2n multiplied by minus 1 is minus 2n. Same down here, 2n times minus 1, minus 2n again. And finally, minus 1 multiplied by minus 1, minus multiplied by minus gives us a plus. So this becomes 4n squared minus 2n minus another 2n, in total is minus 4n plus 1. So this blue one here, I'm subtracting away all of 4n squared, 4n minus 4n plus 1. So now what we're going to have, I'm going to have 4m squared minus 4n squared and then the plus 1 and minus a positive 1 will cancel, so those two will essentially disappear. And then I'll also have this 4m, then minus a 4n, minus a minus makes a plus, so then we have plus 4n, like so. And so this bit here, the 4 brackets m plus n, I can then just look at this and factorize out the 4 brackets m plus n from there. So that becomes, but how to involve this over here? Well, this for me really is a bit of a fudge in terms of it's not normally a question you'd see. But 4m squared minus 4n squared, I'm hoping you could agree with me, that looks very much like a difference of two squares. So factorize out the 4, we'd have m plus n, and on the inside we'd need m minus n. So that first two bits, that's done. However, we also need an extra 4m and an extra 4n. So the trick now is, well, if I just imagine this 4 popping into the brackets, I'd have 4m. What do I multiply 4m by to get 4m? That'd be 1. Then 4n what would I multiply that by in this bracket to get 4n? Again, 4n multiplied by 1 would keep it as itself. So inside here, I just need a plus 1. And then you've proven it as to be the case. You've expanded it all out, refactorized, and therefore shown that the left-hand side equals the right. If factorizing from this into what I've got here freaks you out or unnerves you, a way around the question would be to get to this stage here. Okay, so get to this bit. And if you're not sure how this factorizes into this, well, think about this one here. Could I expand this and then actually expand it out and simplify it to that? So sort of meet them in the middle in terms of working steps in the middle and show that this working step from the left is identical from this working step to the right. Therefore, that is another way of showing that the left-hand side is equal to the right as well. So if I just think about this one here and imagine 4m plus n in its own bracket, I'm going to imagine this as being 4m plus 4n, like so. I can now consider expanding out 4m plus 4n by m minus n plus 1 here, for example. And if I did this, I'd get these 6 terms: 4m squared, 4nm, minus 4mn. So as you can see, the 4nm will cancel the minus 4mn, like so. And I get the minus 4n squared plus 4m plus 4n. So simplified down, I'd get 4m squared plus 4n squared plus 4m plus 4n, which I can then see and explain to the examiner that's exactly the same as what we had from the left-hand side when it's simplified. Therefore, 2m plus 1 all squared minus 2n minus 1 all squared equals 4 brackets m plus n brackets m minus n plus 1 close brackets. Sophia now says that the result in part A shows that the difference of the squares of any two odd numbers must be a multiple of 4. Is Sophia correct? You must give reasons for your answer. So she's saying it's showing the difference of the squares of any two odd numbers must be a multiple of 4. So she's saying it's about a difference. Well, to find the difference between two numbers or two values, you do one number subtract another. So this is finding the difference. So she's right on that front. She's then saying it's a squares. Well, this is one value squared. This is a value squared. So it is a difference. She's correct there. These are squares. And she's saying any two odd numbers. Well, 2m will be an even number because it's a multiple of 2. So 2m plus 1 is 1 more than an even number, so that will be odd. 2n will be even because 2 times n is obviously going to be a multiple of 2, therefore even. But because I'm taking away 1, 2n minus 1 will be 1 less than a multiple of 2. 1 less than an even number is also odd. So yes, they are going to be both odd numbers. And then does this show that it's a multiple of 4? Well, she's worked out that the difference between these two squares of different odd numbers is equal to this expression here. And because she has a 4 factorized out at the front, that means 4 multiplied by something times something. In other words, something multiplied by 4, it is therefore a multiple of 4. So essentially, in a nice concise way, agree with her and just say something like this. Essentially, yes, she's correct. 2m plus 1 and 2n minus 1 are both different odd numbers, and then just stress the fact that the 4 factorized out at the front shows that the value is a multiple of 4. Question 17, a fractional power. Work out the value of 8 over 27 all to the power 4/3. I'm going to get a picture of a flower here. Why, you ask? Well, I will explain. So a flower always starts with the roots, and we're going to do exactly the same. We're going to take our example from nature. So we're going to start with our root as well. The root is at the bottom, so we're going to do the bottom of our fractional power first. Like with a flower, the bottom comes the roots. So the bottom number here, we also assume to be our root. So for example, if this is a 2, that would mean square root. If the bottom number is a 3, that's a cube root, and so on. Once you've done the bottom number, I mean to say, we then focus on the top. The top of the plant is the flower, so the flower, the top rhymes with power, So n by doing the power, which is the flower. So the bottom number is the root, do that first, then move up and do the flower, the power, last. So without the silly talk, the first thing I'm going to do is do the cube root of 8 and the cube root of 27, because the bottom numbers are 3, and we do that as the root. So it's the cube root of 8 all over the cube root of 27, and then we'll do that power 4 second. That power 4 is the top one, so we're going to do that at the end. So, cube root of 8. It's a non-calculator paper, so I've always been thinking these cube numbers will likely be quite nice and easy. That equals is too high, that's bugging me for some reason. I should learn to chill out. Anyway, so cube root of 8, what number multiplied by itself 3 times gives us 8? Well, that number would be 2, because 2 multiplied by 2 multiplied by 2 gives us 8. In the same way, the number multiplied by itself 3 times to give us 27 is 3. 3 cubed is 27. So we've done the cube roots. We now do both numbers to the power 4. So the top, 2 times 2 times 2 times 2. 2 times 2 is 4. Multiplied by 2 again is 8. Multiplied by 2 for the 4th time gives us 16. And at the bottom, 3 to the power 4. 3 multiplied by 3 is 9. 9 multiplied by 3 a 3rd time, 27. Multiply 27 by 3 gives 81. So 8 over 27 to the power 4 thirds is 16/81. Question 18 is some circle theorems now. So A and B are points on a circle, centre O. DBC is a tangent to the circle at B. That's going to be key information here. Angle AOB equals x degrees. We have to show that angle ABC is equal to half of x. You must give a reason for each stage of your working. Wow. So let's just take this nice and slowly, step by step. The first thing from the diagram I'd notice is that OB and OA are both radiuses. Because of that, this triangle OAB must be isosceles, because 2 of its sides are radiuses. So OB is OA, both radiuses, or to be fancy, radii. So therefore, triangle OAB is isosceles. We're just giving reasons as soon as we can from minute 1 to back up what we're saying to the examiner to make sure we've got the best chance of getting full marks. So this is isosceles. So what this means now, we can work out this angle OBA and angle OAB in terms of this angle x. So angles in a triangle add up to 180. X of those 180 has already been taken up at O. So the degrees left are 180 minus x. So I need to share equally 180 minus x between this one and that one. So it's 180 minus x divided by 2. So angle OBA and this one as well, OAB, would both be 180 minus x divided by 2. I can now think of this as 2 separate values. Half of 180 is 90, and half of x is half x. So this can be written as 90 minus half of an x. So that's what angle OBA is here. Coming back to what the question says near the beginning, we were told that DBC is a tangent to the circle at B. Therefore, this angle OBC must be 90 degrees, because a tangent always meets a radius at 90 degrees. That's one of the circle theorems we need to quote next. So, because DBC is a tangent, we can say OBC is 90, because tangent meets radius at 90 degrees. So, we're now getting closer to working out this angle ABC. So angle ABC means the angle as we go from A to B to C. So it's just this bit here, which I'm going to highlight in blue. And hopefully now you can see this blue angle is all of the 90-degree angle with this yellow slice taken away. So essentially, the angle ABC is going to be angle OBC 90 minus this yellow one, so minus angle OBA. So ABC is angle OBC, which is 90, minus OBA, which we worked out from before, was 90 minus half of an x. So 90 take away 90, that cancels. Then I've got minus half of an x. Minusing a minus makes a plus, so therefore angle ABC is minus half of an x, which is positive half an x, which is exactly what we wanted to prove. So finally we've done the question. Question 19. Solve 1 over x minus 1 over x plus 1 equals 4. Give your answer in the form a plus or minus b root 2, where a and b are fractions. So essentially this is a fraction subtract another fraction. The rules from year 7 still work. Okay, so if you're doing one fraction subtract another, we need to have a common denominator. So I'm just going to write the fraction out here to make it nice and clearer. What I could do is multiply each denominator by the other one. So what I'm going to do here, to ensure I get the same denominators on each, I'm going to multiply both top and the bottom of this first fraction by x plus 1. And over here I'm going to multiply top and bottom of this fraction by x, because x is the denominator of that other fraction. So I'll then get x plus 1 at the top over x brackets x plus 1 minus 1 times x becomes x all over x brackets x plus 1. So at the minute I'm not even touching this thing about being equal to 4. I'm just trying to get this into an easier form. So now I've got a common denominator, so I can put it all over next this common denominator of x brackets x plus 1. So now x plus 1, take away an x, of course, just gives 1. So therefore, this fraction here simplifies down in the end exactly to 1 over x brackets x plus 1. So all of this here can be rewritten nicely like so. So therefore this equation can be solved by thinking of it entirely differently. So if I just bring this over here, I'm going to rewrite what's on the left as this now. So I'm going to solve 1 over x brackets x plus 1 equals 4. But I'm going to rewrite 4 as well. I'm going to rewrite 4 as 4 over 1. Okay, now I'm going to solve this fractional equation. If I've got one fraction equals another, I can cross multiply. So I can say that 1 multiplied by 1 equals 4 multiplied by x brackets x plus 1. So the next step from here, I can say that 4x x plus 1 must equal 1 times 1, which is 1. I can now expand this out. So 4x times x is 4x squared. 4x times by 1 is 4x. And that equals 1. To solve a quadratic, I'm best normally having one side equal to 0. However, because here it's got a surd in it, I can now actually safely assume that I'm going to have to complete the square or something awkward. So I can go one of two ways now. I could either complete the square or I could use a quadratic formula. Okay, I'm going to show you now one of two different ways. So over here on the left hand side, we're going to complete the square. Okay, so how to do this by completing the square. Well, to complete the square, we can't have any coefficient in front of this x squared. So if we do it this way, and if I just take this here, bear with me. Okay, so doing it this way around, if I'm going to complete the square, what I'd need to do, I'd need to divide everything by 4 because I can't have any coefficient of x squared. So I'd have to divide everything by 4 here. I'd then get that x squared plus x equals 1/4. I can now complete the square on the stuff to do with the x. So x squared plus x now becomes x the coefficient of x here, which would have been 1, I half that, so I have x plus a half squared. Subtract away this value here squared, which is a quarter, because a half times a half is a quarter, so minus off that quarter, and that equals a quarter. The next step, if I add a quarter to both sides of this, the next thing I'd arrive at would be that x plus a half all squared is a quarter, plus a quarter, which of course is a half. Then, if I square root both sides, I get that x plus a half equals plus or minus the square root of a half, like so. Now, just bearing in mind that I want here what my answer to be. It says I want it in the terms a plus b root 2, where a and b are fractions. So I've got this a half here, which is absolutely fine, but this plus or minus root a half. And so if I just consider a square root of a half for a second, square root of a half, that's the same as the square root of 1 divided by the square root of 2. I can then make this into a equivalent fraction by multiplying top and bottom by the square root of 2. So root 1 times root 2 becomes root 2. Root 2 times root 2, or root 2 squared, becomes 2. So the square root of a half is actually the same as a half of root 2. Okay, so what I'm going to say here is this can be rewritten as being plus or minus half of root 2. Therefore, the final step, if I subtract a half from both sides, have that x equals minus a half plus or minus a half root 2. So that's method 1. That's using completing the square. The second method we could have used is quadratic formula. So if we had have done the quadratic formula instead, we'd need to make sure that the right-hand side of the equation is equal to 0. So to use the quadratic formula, we'd have to take this form here and subtract 1 from both sides. So we'd need to use this form to solve it. It would have to have it in the form 4x squared plus 4x minus that 1 equals 0. In this form, we can now use the quadratic formula, which is as follows, in case you forgot it. So it's for x is minus b plus or minus square root of b squared minus 4 times a times c all over 2a. And so using the quadratic formula, we'd say that x equals minus b. B here is 4, so minus 4 plus or minus the square root of b squared. So for us, that's 4 squared minus 4 multiplied by a here is 4, multiplied by c. Our c value here is minus 1, not 1. There's a minus sign in front, so be careful and sure you put minus 1. And all of that's going to be divided by 2 lots of a, where 2a means 2 times 4, because our number at the front is 4. So with a bit of neating it up, we can now get to the same conclusion. So we've got minus 4 at the front, plus or minus. So we've got 4 squared. 4 times 4 is 16, times minus 1 is minus 16. So 16 minus minus 16 gives 32. So that's plus or minus square root of 32 all over 8. Need a bit more space. Well, the square root of 32 is the same as root 16 root 2. So if I just call this now root 16 root 2 all over 8, a bit more space needed. Also, we've got minus 4 plus or minus 4 root 2 all divided by 8. So I've got minus 4 over 8, which of course is minus a half, plus or minus 4 over 8. 4 over 8 is the same as a half of root 2. So different method, same conclusion, as of course you'd expect. So whether you like completing the square or quadratic formula, you can take your pick. If you don't like either, pick the one you hate least, I'd say. Anyway, let's move on to the next one. Question 20. Alfie has 11 cards. He's got 3 blue, 7 green, and 1 white. He's going to take at random 2 of these cards. We need to work out the probability that he takes cards of different colours. So, he's picking 2 cards, so we can consider this as a 2-step tree diagram. So for the first pick, he could either pick a blue, a green, or a white. And for the second pick, again, he could pick either blue, green, or white. So for the first pick, the chance he picks a blue one, well, if 3 are blue out of a total of 11, the probability of picking blue first would be 3/11ths. If 7 are green out of 11, the chance of picking green first will be 7/11ths. And if 1 out of 11 is white, probability of white would be 1/11ths. Now for the second stage. Imagining a blue was picked first. If a blue was picked first, these cards aren't replaced. There'd be 10 cards left, and if a blue was picked first, there'd be only 2 blue left now. So for the second pick, chance of picking a blue, if a blue was picked first, would be 2 out of 10. If a blue was picked first, we'd still have all the 7 green left, so chance of picking a green if blue was picked first would be 7/10, therefore 1/10 chance of picking a white. If the first pick was a green card, the chance of picking a blue next would be 3/10, because still all 3 of those cards which are blue are still there. If 1 green was picked, there'd only be 7, so there'd only be 6 greens left now out of 10. If a green was picked first, there'd still be about 1 white card left now out of a total of 10 cards. Finally, if white was picked first, the chance now, it could either only be a blue or green. You can't have white being picked twice, because there's only 1 white card there anyway. So if a white one was picked first, the chance of a blue being picked next would be the 3 blue which are still left out of the 10 cards, and therefore 7 out of 10 chance of picking a green. So our question here is to work out the probability if it takes cards of different colours. So how could we do that? So different colours, there's a few different ways this could be done actually. One way, we could have blue first and then green, or we could have blue and then white, or the second card, so first card could be green and then blue. Green and green wouldn't work because green would be the same. We could have green and then white, or we could have white and then blue, and finally white and then green. So a bit of work to do, but as long as we keep our heads, it is doable. So the probability of picking cards of different colours would be the probability of blue-green plus probability of blue-white, green-blue, green-white, white-blue, or white and green. So the chance of picking blue and then green, for example, would be 3/11ths multiplied by 7/10. The chance of picking blue and then white would be 3/11ths multiplied by 1/10, and so on and so on. So we're going to have lots of different fraction calculations to do. Here they all are now. But what you'll notice is the denominators are all going to be 11 multiplied by 10. They're all going to be 110 as the denominator. And these numbers, all we're doing, on each set of branches I've ticked, I'm just multiplying the 2 fractions together. So first of all, 3 times 7 gives a new denominator, so a new numerator of 21. 3 times 1, new numerator is 3. 7 times 3, that numerator becomes 21. And all the denominators will be 110. So though it looks hard work, it's actually not as long-winded as what it would seem. So calculating all the denominators as being 110, the numerators, 3 times 7 is 21, 3 times 1 is 3, that becomes 21, 7 times 1 is 7, 1 times 3 is 3, 1 times 7 is 7. Total up 21, 3, 21, 7, 3 and 7 gives you a total of 62. Therefore, the overall combined probability that he takes cards of different colours, using these 6 different combinations added together and simplified, would be 62 out of 110. Question 21, we have a sketch of part of the curve of equation y equals cos x. P is a minimum point on the curve, there it is. Write down the coordinates of P. This question strongly is weighted towards people that have revised the actual trig graph functions. If you don't know what the graph of y equals cos x looks like, you haven't really got a hope. So I'm just going to give you a very brief overview of what the graph of y equals cos x is and its key points. The first thing is its period or its wavelength is 360 degrees. It goes through a cycle of its waveform every 360. So it starts at the top at a peak, it next gets to the other peak after 360 degrees, then it repeats the same cycle for another 360. The coordinates, there's 5 main ones to know. So the first one here, where it crosses the y-axis, is at 0, 1. The first x-intercept is 90 degrees and 0. The minimum, it's going up in multiples of 90, look, is 180 and minus 1. Coming back through the x-axis for the second x-intercept, that's 270 and 0. And back to the top again where y is 1, 360 degrees and 1. So obviously you can see between 0 and 360, that's a 360 degree difference, and it's done one cycle of the wave. Essentially though, we're wanting the minimum, whoops, wrong colour, I think I'll go for a yellow. So P is a minimum point on the curve, coordinates of P are therefore 180 and minus 1. So P, very simply, is just 180 minus 1. Question 22, we have a triangle ABC, and we have to work out the value of sine of ABC. So we're not asked to work out the actual angle, just need to work out the sine of the angle itself. So give your answer in the form m over n, where m and n are integers. That just means m and n can be whole numbers and are allowed to be negative. So we need to recall this piece of information, which is the sine rule. So sine A divided by A would equal sine of angle B divided by side B would equal sine of angle C divided by side C, where big A and little a are the angle and side opposite to each other respectively, same with big B and little b, and also big C and little c. So what we would tend to do is whatever we're trying to work out, label that either little a if it's a side or big A if it's an angle. So because we're interested in sine ABC, where ABC is an angle, I'm going to suggest we call this one here, which is ABC, call that big A. And as well as that, what we're going to need here is some knowledge of exact trig ratios. So I'll come to that in just a second as well. So sine ABC is the one at B. Like I've said, because that's one we're interested in working out, call that one big A. Opposite to big A, we put this as little a. So opposite to big A, side little a, call that 6.5. So 6.5 is our little a. And then what we need is another angle and the side opposite to the other angle, which we need. So luckily we have that. We've got a 30-degree angle, and we know the side opposite to it is 10.7. So we can now also say, if that's A and that's little a, we can also have big B and little b as 30 degrees and 10.7 respectively. So now we've got a matching pair. So we've got A and 6.5. We also now have 30 and the 10.7 opposite to it. So now we can apply the sine rule, which is essentially this. So sine of A divided by 6.5 equals sine of 30 divided by 10.7. Because it's a non-calculator paper, this is why they're not asking you to work out what ABC is. You can't do inverse sine for lots of angles in your mind. However, sine 30 is one of these exact ratios which you actually need to remember for your exams. So sine 30, if we refer to this table, there are methods for remembering these, so you can remember this table easier than just remembering it just randomly every single number. I'm not going to go into it here, but there are videos for that. You can hopefully see that when sine is 30 degrees, its value is 1/2. So we can use this information and plug in that sine 30 is 0.5. So what we need to solve now is this equation, without a calculator of course, sine A divided by 6.5 equals 0.5 divided by 10.7. So to make sine A as the subject, I need to undo this dividing by 6.5 by multiplying both sides of this by 6.5. So if I multiply the left and the right by 6.5, what I'd then next get would be sine of A would equal 0.5 multiplied by the 6.5, all divided by 10.7. So 0.5 times 6.5. Let's just think about this for a second. So again, like the question earlier in the paper when we were multiplying decimals, forget the decimals exist and think of it as what the numbers would look like if they didn't have any decimals in at all. It would look like 5 multiplied by 65. So 5 lots of 65 is half of what 10 65s would be. So it's going to be half of 650. So 650 divided by 2, this is just my way of timesing by 5. I multiply by 10 and then half it. So half of 650 would be 325. And so 0.5 times 6.5, remember to put the decimal back in, 1, 2 decimal places in this question, 1, 2 decimal places in the answer. So it must be 3.25 over 10.7. However, we're asked very clearly to give m and n as integers. These are decimal numbers. So to get both of these values as integers, I'd need to multiply both by a certain value. I'm suggesting the easiest thing to go for here is multiplying both by 100. So if I multiply the bottom by 100 and the numerator by 100, we get it in the form 325 at the top, because 3.25 multiplied by 100 is 325, and on the bottom it would become 1070, because 10.7 multiplied by 100 gives us 1070. Now this fraction could be simplified, however the question doesn't ask us to do that. It just says write it in the form m over n, where m and n are integers. 325 and 1070 are both integers, so we're under no obligation to do anything else to this value. You could, if you really wanted to, try and simplify it down, but by doing so, A, you're wasting time, B, as well, just giving yourself an extra opportunity to make a final mistake. So don't even give yourself a chance to mis-simplify, just leave it like it is. Move on to the next question. Question 23, we have a geometric sequence, the first 5 terms of it, and we're asked in part A, we're asked to work out the next term of this sequence. So essentially, what's this missing value going to be over here? So what makes a geometric sequence is the fact that as you go from one number to the next, rather than adding the same number or subtracting the same number, as with a arithmetic sequence, with a geometric sequence, we're multiplying by the same number as we move from one to the next. And that number we multiply by is called the common ratio, little r. So what we need to do here is to find this number, little r, which each number is being multiplied by as the sequence moves along. So it's not obvious to see what r would be. For example, to go from root 5 to 10, it's not immediately obvious as to see what's happened. What is more obvious, I believe, is to see what's happening as we go from 10 to 20. Well, obviously, to go from 10 to 20, the number's been doubled, the whole number's been doubled. 10 times 2 gives 20. And obviously, there's also been a root 5 been multiplied. So overall, to go from 10 to 20, we must have been multiplying by 2 root 5. In the same way as we go from 200 to 400, to get 200 to 400, we've multiplied by 2. And again, because it's 400 multiplied by root 5, the overall factor must have been to multiply by 2 root 5. This also works as well because it is A, a common ratio, and B, because, well, we can see that it works for every consecutive number in the sequence. So from root 5 up to 10, if we were to multiply that by root 5 multiplied by root 5 would give us 5, and then times it by 2 would give us 10. So essentially, we have worked out the common ratio has to be 2 root 5. So using that fact, what we know is that the next term along will be the last term we've got listed, 400 root 5, multiplied by this common ratio, which is 2 root 5. So if we multiply the whole numbers first, 400 multiplied by 2 gives us 800. and then root 5 multiplied by root 5, that gives us 5. So it's 800 multiplied by 5, which overall is 4,000. So therefore, for part A, the next term of sequence would be 4,000. So the sequence is growing pretty fast. Question 23, part B, we're told that the fourth term of a different geometric sequence is 5 root 2 over 4, and that the sixth term of this same but different geometric sequence is 5 root 2 over 8. And we're told now that all the terms of this sequence are positive. Work out what the first term of this sequence would be, showing all working steps. So we've got the first 6 terms of this sequence. So I'd suggest to list them out and give some spaces to work out the ones which you've not quite worked out yet. So this would be my suggestion, and fill in the ones we know. So we're told that the fourth term is 5 root 2 over 4. So I can fill in that the fourth term is 5 root 2 over 4. In the same way, the sixth term is 5 root 2 over 8. So I'll just put here 5 root 2 over 8. But of course, it's still a geometric sequence, which means that to go from one term to the next, we're multiplying by that same common ratio. So just to add this bit of information in, we can now think and see quite clearly that to go from the fourth term to the sixth term, we've multiplied by r once to get to the fifth term. Then to go from the fifth to the sixth, we must have multiplied by r again. So 5 root 2 over 4 times r, in other words, 5 root 2 over 4 multiplied by r squared gives 5 root 2 over 8. So this is how we set up an initial equation to work out what r is. So the fourth term times r times r squared gives 5 root 2 over 8. So what we can do here is try and work out what r squared is by simplifying both sides. And to be honest, what we can do is we can cancel off a lot on the top and the bottom. So first of all, what I'd suggest will be to divide both of these fractions by root 2. So if I cancel off a root 2 over here and a root 2 over here, I then get 5 quarters of r squared equals 5/8. If I now get rid of the fractions, I can now multiply both sides by 8. There's a few different ways you could go around this, but I'm just doing it this particular way. So multiplying both sides by 8. So 5 times 8 gives 40. 40 divided by 4 is 10. That gives me that 10r squared equals 5. I can then divide by 10 if I wanted to get r squared on its own. So therefore r squared would be 5 over 10, which is obviously a half. So therefore the common ratio r must be the square root of a half. However, this sequence is given in terms of root 2, not in terms of root a half. So what we can do here is actually write this in terms of root 2 instead of being in terms of root a half. So the square root of a half is the same as the square root of the top, 1, divided by the square root of the bottom, 2. We can now rationalise the denominator by multiplying both top and bottom by root 2. So root 1 times root 2 becomes root 2. And on the bottom, root 2 multiplied by root 2 is just 2. In other words, we're dividing by 2, which is a half. So the common ratio is 1/2 root 2. So what's happening here is, as we go along, as we go this way, we're multiplying by 1/2 root 2. But because we want to go from the fourth term back to the first term, we're actually going the other way round. So what we're doing isn't obviously going that way, we're going to actually have to go the opposite way round now. So from the fourth term down to the first term, we're going the opposite way, so we'll be doing the opposite thing. So instead of multiplying by 1/2 root 2, each step will be dividing by 1/2 root 2. So the first term, we can now consider how to work this out. So if we start at the fourth term, which is 5 root 2 over 4. Going back, we'd have to divide by half root 2 once, divide by half root 2 again, divide by half root 2 for a third time. So we'd actually be dividing by half root 2 3 times. So we're actually dividing by a half root 2 to the power 3, because it's half root 2 divided by half root 2 divided by half root 2 again. For example, if you have to divide by 2 3 times, it's the same as dividing by 2 cubed overall. So we can consider this as a fraction and simplify. So we've got 5 root 2 over 4. Then a half cubed becomes 8. Root 2 cubed, root 2 times root 2 becomes 2, times another root 2 gives just root 2. So this now becomes 5 root 2 over 4, divided by, now this can simplify quite nicely, so 1/8 times 2 is a quarter, times root 2, so I've got a quarter root 2. In other words, I've got root 2 divided by 4. Now, to go from one fraction divided by another and actually work out what that fraction is, it's obviously the good old keep, change, flip. So we're going to keep the first fraction, change the divide to a multiply, and flip the last fraction by taking its reciprocal and flipping it on its head, essentially. So we're going to have 5 root 2 over 4 multiplied by 4 over root 2. So the 4 on the top and the bottom will then cancel, as will this root 2 on the top and the bottom there. And so we're just going to be left with 5 multiplied by 1, essentially, because that's cancelled and that's cancelled. So we just have 5 as our first term. Everything cancels, essentially, apart from the 5. Question 24, we have a solid sphere and a solid cone. All measurements are in centimetres. The volume of the sphere is equal to the volume of the cone. Find the ratio of r to h, giving your answer in its simplest form. Okay, so the volume of the sphere, using this formula here, is 4/3 pi r cubed. And then we're told that that is equal to, in other words, equal signs, the volume of the cone. The volume of the cone is 1/3 pi r squared h. 1/3 pi r squared h. So we can simplify this down and then finally work out what the ratio of r to h is. So what I'm going to suggest we do is we can cancel pi on both sides of this. So divide by pi, and then we can also multiply both sides by 3. So if I multiply this one by 3 and that side by 3, I'd then get that 4r cubed equals r squared h. I can now divide on both sides by not just r, but by r squared. I could have done that in one step earlier, you may be thinking, and if you're comfortable doing that, by all means. So this side, 4r cubed divided by r squared is 4r. r squared h divided by r squared is h. So therefore, I can see here that h equals 4r. But what I'm wanting is a ratio of r on one side and h on the other. So just to do this here clearly, because it's very easy to get these the wrong way round if you're rushing or under the pressure of exams, for example. So I want r first, h second. Well, we've just been told here through our working that h is 4r. So if I leave h as 4r, because h is 4r, it says, and I'll leave r as, well, just r, then if I divide both sides by r, I'll then have a ratio of r to h. r divided by r is obviously 1, and 4r divided by r gives me 4. So therefore the ratio of r to h is simply just 1/4. Part B, we have a different solid sphere now and a different solid cone. All measurements still in centimetres. The surface area of the sphere this time is now apparently equal to the total surface area of the cone. So surface area of the sphere equal to the total surface area of the cone. Now again we need to find the ratio of r to h, but this time we're being asked to give our answer in the form 1 to root n, where n is an integer. So the surface area of the sphere, well, we're told here that it's 4 pi r squared. So we can therefore set 4 pi r squared equal, because it does say equal to, the total surface area of the cone. Now for the cone, it comes in two different parts. We've got the curved surface area, which is pi r L. So what it means by total surface area, you've got the curved surface area, which goes around here, and then also you've got the circular base, which must not be forgotten. That's why the word total's been highlighted, sorry, not highlighted, put in bold, just to make that point clear to you, not to make that mistake. Total surface area means a curved bit, plus as well this circle underneath. So pi r L for the curved surface area, plus of course for the circular bit of the base, area of a circle is pi r squared. So what we can now do again is simplify. So looking here, because everything's got a pi in it, we can divide everything by pi, basically just cancel through by pi, like so. And again, because everything has an r in it, we can also divide both sides by r. So dividing through every term by r, I then get 4r. That leaves me now just with L, and r squared divided by 1r leaves me with r. So 4r equals L plus r. If I now treat this as an equation and then subtract r from both sides, I then see that 3r equals L. In other words, if I think of this as L equals 3r, it will make much more sense now when we have a look at our diagram of this cone. So setting this as a ratio of L and r, so L and r like so. If L is 3 times r, and leave r as just r, if we divide both sides of this ratio by r, we can see that for every 3 units that L is, r is just 1 unit. So thinking of this as now a right-angled triangle, we can now think about what h is, where h is obviously the vertical height of this cone. So h is a perpendicular height, like so. So actually we can use Pythagoras to work out what h is going to be. But what we do know, if ratio of L to R is 3 to 1, then I could imagine in terms of units that L is 3 units and R is 1. Based off this, I can then work out what h is, as a ratio at least of R to L. So h squared plus 1 squared, using Pythagoras, equals 3 squared. 1 squared is just 1, 3 squared is 9. Subtract 1 from both sides, h squared equals 8. And square root both sides, therefore h would be the square root of 8. So what we found here is actually a combined ratio of the vertical height to the slant length to the radius. So we've got root 8 for the slant height being 3 and a radius of 1, but because we just want here a ratio of r to h, we just want here the r first, which is 1, and then h second, which is root 8. So therefore, the ratio of r to h is 1, 2, root 8. That's the last part of the last question complete. Therefore, the whole exam paper has been talked through. That was quite epic, I think. I do hope you found some of it useful, though. Thank you very much for listening, even if it was just for 5 minutes or even 5 seconds here or there. I'll hope to see you all again soon.